Sharks.
Hello.
And hello, everybody. It's good to be here. I'm going to take us on a little journey today in 7 minutes. We're going to start in Colorado. We're going to go through the skin. We're going to take some drugs with us through the skin, and then we're going to end up back in Colorado. So to start, my name is Ryan Beal. I'm a biophysical chemist and physician by training and degree, and I'm from Colorado. This is a picture of me running on top of Mount Quandary. It's one of Colorado's 14,000-foot peaks just outside of Breckenridge, Colorado. So why am I showing this? Well, it's beautiful to me, and we are at an aesthetics conference, and it's that same beauty that attracted my maternal grandparents to Colorado when they immigrated from northern Italy. It reminded them of the Alps in Italy. But what kept them in Colorado what was below the surface. You see, they were miners, and there was gold and silver in them there hills. And similarly, with skin, we can all appreciate the beauty of the surface, but where we find the real beauty at Dyve is what's just beneath the surface. The biology and the structures beneath the skin and the vasculature and subcutaneous fat. You see, the skin is an excellent barrier. It's very good at doing what it's supposed to do, which is keep water in and keep everything else out. But it could be something more. You see, the skin is structured very much like a brick wall, where the skin cells are the bricks, and the lipid between them is the mortar, and as you get deeper into the skin, you run into rebar, which is very much like the junctional proteins deep in the skin. And at Dyve, we're taking that surface level of the skin and turning it into a drug delivery portal. We've developed technology that transiently fluidizes that mortar, fluidizes that lipid matrix, and modulates the junctional proteins deep in the skin. In essence, creating two valves where we can control the delivery into the skin and then the delivery through the skin into the vasculature. We're exploiting it in a number of areas, but what's most important is that platform technology functions as if we've got billions of little microneedles in a cream. We can deliver drugs with needle-like speed and better than oral bioavailability, and without the Cmax-driven adverse events that you typically see with a drug. What is it? Well, at its core, it looks like a beautiful topical moisturizer. It's some powerful science packed into an emulsion. It's medically intuitive, patient-friendly, and it's topical. We can load it into a patch, we can load it into thin films, but it serves as a very intuitive, patient-friendly topical administration of drugs. Now, I'll spotlight a few of the things in our pipeline, but I won't go into great detail. But we have a pipeline that consists of both internally developed products. We're focused on oncology, immunology, and aesthetics. And we're also working on 8 undisclosed drug targets with some of our partners in big pharma. I'll flip through a couple examples to show you the power of the technology. This is DYV600. This is a drug we're developing for the treatment of hyperpigmentation and melasma. This is a drug with known biology. It's well understood that if you inject this drug into the skin, you can achieve tremendous results. Unfortunately, it requires injections every square centimeter once a week to be effective. But we can apply this drug topically twice a day, and this is the result you see in a patient after 30 days of BID topical administration. This is a patient that was treatment resistant to existing therapies. Similarly, we can go from the skin a level deeper. Here we're using a cell membrane cytolytic to drive adipolysis. This is 30 days post-BID application of a topical adipolytic in a flank fat study. We continue to push this forward. And the idea is we know the biology, we know these drugs work, but is there a better, more patient-friendly, convenient way to deliver the drug that avoids needles? Well, those are kind of bread and butter applications. We're also excited about how can we deploy this technology across a couple moonshot ideas. I'll highlight a couple of them. One in oncology, which I know we're not an oncology conference, but I'm very excited about what we're doing there. And then in aesthetics. On the oncology side, we're leveraging pH modulation. We just presented some data up in Orlando. It's good to be here in Miami, by the way. But I just presented data on Tuesday on some of our studies in oncology, where we're taking pH modulating agents through the skin and targeting acidic microenvironments. In oncology's case, we're going after the acidity of the tumor microenvironment. We're also using the same approach in gout. Many of you will recall, some of you will probably suffer from gout. It's extremely painful, and you may recall treating gout patients early in your training. Gout is very painful, and it's the paradigm of acute inflammatory pain. But by getting these alkalizing agents into the joint topically, we're seeing relief in our patients as early as 15 minutes. Now that's in oncology and immunology, but I'm excited to share it. But on aesthetics, the moonshot is a topical toxin. Many people have tried it. It's had different degrees of success, but ultimately nothing's made it to market. For us, this is something we're actively working on now across toxins. It's early days, but it answers a critical question for us. We've driven a lot of different molecules through the skin, and largely it seems to be independent of physiochemical characteristics, solubility, size, et cetera, but we haven't tested a really large molecule. The toxins give us a really nice way to do that. It diversifies the risk. There are multiple opportunities for success. We can go after skin quality, we can go after hyperhidrosis, and obviously the big one, getting it down to the neuromuscular junction. So we're currently in the midst of testing this. I don't want to minimize the challenges of getting this through the skin. This is a long shot. It truly is a moonshot, but we believe if anyone can do it, we can. It also opens up a big opportunity for Dyve. If we can get a toxin through, it opens up the world of antibodies, et cetera. So until we meet again, you can see the beauty on the surface, but where we find beauty is a little bit deeper, just beneath the surface. Excited to share with you what Dyve's up to, and I welcome follow-on conversations, advice, ideas, and look forward to much more follow-up. You can contact me here and find more information on our website, but I'll open it up for questions from the sharks. Thank you.
Thank you.
Hey, Dan, it's great seeing you here. It's a pleasure. So congratulations, you seem to have found a way to bypass the gastrointestinal tract for some products, many of the products that we would like to do that. And I won't go into that question, which would be, you're raising the bar for pharmacodynamics and pharmacokinetics, because that the FDA is going to ask your topical and the systemic, et cetera. I'm not going to go there, but you say that you transiently and reversibly affect the lipid matrix, right? How can you be sure that it's so transient that it will just be enough to pass the molecule through, but you're going to still keep the integrity of the barrier? I mean, that to other insults other than our molecule, can't you just open it up for other things?
Yeah. So I'll answer it two ways, one scientifically and one anecdotally, for what the anecdotal side is worth. Scientifically, we know using MALDI time of flight studies where we can see that modulation in the flux of fatty acids in the lipid matrix, you can actually observe how they shift and how they return. And so in essence, we're creating a bit of a ratcheting of these fatty acids in the lipid matrix that is very transient. From a biochemistry perspective, it's as if we're disrupting an equilibrium, the body's seeking to re-equilibrate and then go back to normal. So it's a very transient. Now that's the scientific explanation. Anecdotally, we do have a product on market buffering lactic acidosis in athletes. And one of the users of this product are some of the Olympic teams. Now the US Olympic Committee takes that very seriously and was worried about bringing other molecules through the skin if you're opening up those channels. They studied this as well anecdotally and approved it for use. And so a bit of the scientific and anecdotal. The other key thing is here when we're modulating or fluidizing that lipid matrix, this isn't a solvent-based approach. So historically, one of the ways you would take drugs through the skin is you would use high-powered solvents, in essence, dissolving that lipid matrix. And there you would be breaking down the barrier and creating dry, cracked skin, and that's how you would observe it clinically. In this case, we're not doing anything with solvents. In fact, we're adding more fatty acids to the matrix and if anything, increasing the integrity of the skin over time.
Interesting.
Irina, do you have a follow-up?
Yeah, my follow-up is actually a little bit on the same, in the same topic of science. You mentioned that this affects the tight junctions. That's a phenomenon really in the epidermal compartment. It is not a phenomenon further down in the skin. So I am still confused as to what's that mechanism of action, because it matters if what you're really doing is permeabilizing the lipid matrix. You will be doing that across all the cells inside the skin, which would worry me significantly from a side effect profile once you start delivering other drugs into that domain, because you have immune cells, you've got everything in the skin. It's your biggest organ.
Yeah.
So where are you actually working? Are you permeabilizing that epithelial and stratum corneum? In which case I understand that.
Very much at the level of the stratum corneum. And to us, that's that first gate that we're
Got it.
opening. And so
Okay.
once we've opened that gate, now we're going after the tight junctions that are deeper. But yes, it's localized at the stratum corneum.
It's localized at the stratum corneum. Okay,
Yep.
thank you.
Yep.
As the investor shark, I saw a lot of really interesting things there, but I think about focus. So what is your first product, and what is the timing of that, and what is the expected regulatory pathway with the FDA?
Yeah, so our most advanced product is in the treatment of acute gouty arthritis. That just completed phase 2 studies, and it's heading into pivotal studies. We expect that to be on market in the 2025 timeframe. Now, there are other paths to market through partners with both that are going down both the cosmetic path and the drug path. But our internal pipeline, the furthest along, is the gouty arthritis product. And that is going down a 505(b)(1) pathway,
Yep,
full
okay.
drug pathway.
Good, thank you.
Thank you.
Any other questions, Sharks?
Just as a general comment, what I would say when you go into the world of topicals with the FDA, one of the things to keep in mind is that they really do care about the route of administration of your primary drug that is actually the one that's delivering the efficacy. So to lower your barrier, you have so many different drugs that you're potentially targeting here. Trying to work with something that's already approved for topical administration will really dramatically improve your roadmap through the FDA.
Yep, and that is the bulk of where we're focused, is working with known drugs.
So
Thank you, Irina.
Yep, sorry.
Go ahead, Humberto.
Your clients are pharma companies, right?
Yep.
They're the pharma companies. And many of them have their, you show melasma, you show adipolysis, but you're trying to, ambitioning to go to toxins or cancer drugs. And the efficacy will depend on the molecule rather than your technology, And almost all pharma companies have their own galenic departments. So how are you going to solve that? I mean, how do they give value to your formulation, and how do you fight that not-invented here syndrome?
Well, the not invented here syndrome is a big challenge, there's no doubt, and we beat our heads against the wall for many years to break down that wall. We've now broken it down, and we're working with 2 big pharmas in particular across 8 different drugs. And where they're seeing the value is kind of 2 different stages of the life cycle. About half the drugs we're working on are on-market drugs that are facing loss of exclusivity. They're injected or they're oral. They're looking to shift the route of delivery to maintain that franchise value. And then there's a set of drugs on the other end of the spectrum that are development stage drugs where they're very excited about the efficacy profile, but they've met some delivery challenge that is going to stall promotion of that product from a development perspective. So for example, great efficacy, but GI side effects that they're trying to avoid. They're looking to us to keep that program alive in the development cycle.
Right?
Great, thank you very much.
Thank you.
Thanks.
Thank you, Dan.